Today we will answer a math challenge given by one of our followers. And here's the question. Alright, given this equation, a factorial over b factorial all over a double factorial over b double factorial equals 24, wherein 0 is less than b, and b is less than a, and a is less than 10, then our goal is to solve for the sum of a and b. You can pause this video if you want to give this problem a try. And now, let's answer this question together. So, our goal is to solve for the value of a that satisfies this equation a factorial over b factorial all over a double factorial over b double factorial equals to 24. Then, our goal is solve for the values of a and b, wherein 0 is less than b, b less than a, and a less than 10. So how do we start? Alright, to answer this question, we will use this identity. If we have n factorial, it is equivalent to n double factorial multiplied by n minus 1 double factorial. Now, before we start our solution, let's prove this identity. Alright, we know that n factorial must be equal to n times n minus 1 times n minus 2 times n minus 3 times n minus 4 all the way up to 4 times 3 times 2 times 1. Now, what we're going to do here is to rearrange some terms a little bit. Now, what we're going to do is to make two groups like this. So, we have a group of n times n minus 2 times n minus 4 all the way up to 2. Then we have group for n minus 1 times n minus 3 all the way down to 1. Now, notice, this guy must be the same as n double factorial. And this term, or this expression right here, must be equivalent to n minus 1 double factorial. Therefore, n factorial must be equivalent to n double factorial multiplied by n minus 1 double factorial. Now, let's use this identity to answer this question. So we have a factorial over b factorial divided by a double factorial over b double factorial. Now, take note, the left-hand side of our equation can be written as numerator multiplied by the reciprocal of the denominator. So it looks something like this. We have a factorial over b factorial multiplied by b double factorial all over a double factorial. Now, let's use this identity. So, a factorial can be written as a double factorial multiplied by a minus 1 double factorial. Also, this b factorial can be written also as b double factorial multiplied by b minus 1 double factorial. Now, you can now see a lot of terms cancel out. For example, a double factorial on the numerator and a double factorial on the denominator. Also, b double factorial on the numerator and b double factorial on the denominator. So the left-hand side is simply equivalent to a minus 1 double factorial all over b minus 1 double factorial. And it must be equal to just 24. Now, here comes the trick. We know 24 must be equal to 6 times 4. And it looks something like double factorial, right? Because the difference between 6 and 4 is just 2. Now, what we're going to do is to multiply this number, 24, by 2 over 2. Alright, therefore, the numerator must be equal to 6 double factorial, while the denominator must be equal to 2 double factorial. Therefore, we can say that a minus 1 must be equal to 6 and b minus 1 must be equal to 2. Solving for the value of a and b, a minus 1 equals to 6. Add 1 on both sides, we get that the value of a must be equal to 7. Also, to solve for the value of b, let's add 1 on both sides, and b equals to 2 plus 1, or simply equal to 3. Now, we found the values of a and b. And take note, this satisfies to this condition that b must be greater than 0. That is correct, because 3 is greater than 0. And a is greater than b. That is correct, because a is 7 and b equals to 3. And 10 is greater than A, and 10 must be greater than 7. So maybe this is the only real solution to this question. But again, don't forget our goal. Our goal is to solve for the sum of A and B. So if we get the sum of A and B, we get 7 plus 3. And that will give us an answer of 10. Therefore, our answer to this question, what is the sum of A and B given this equation? And our answer is equal to 10. And as always, we are done.